All right, let's dive in. Today, we're going to peek behind the curtain at a system that's running pretty much every aspect of your life 24/7, and the crazy part is you never have to think about it. We're talking about your body's secret control panel, the autonomic nervous system. Let's see how it all works.
I mean, of course, right? That sudden rush of energy, your pulse just hammering in your chest. Or, on the flip side, that incredible sense of peace when you finally get to relax. You know, those aren't just random feelings. They are the direct result of this hidden network firing off commands inside you. This is the system that knows exactly when to hit the gas and when to slam on the brakes.
And that system is called the autonomic nervous system, or the ANS for short. The best way to think about it is like your body's own personal autopilot. While you're busy living your life, the ANS is humming along in the background, managing all the stuff that keeps you alive: your heart rate, blood pressure, breathing, digestion, even your body temperature. It is the ultimate multitasker, and you don't even have to pay it.
Now, to really get a grip on this, it helps to know your nervous system kind of has two big divisions. You've got the somatic system, that's your manual control. That's the part you use when you decide to kick a ball or type an email. But then you have the autonomic system, which is pure 100% autopilot. You don't consciously tell your heart to beat or your lungs to breathe, it just happens, all thanks to the ANS.
So how in the world does this autopilot actually work? Well, the best way to wrap your head around it is with a really simple analogy. We're going to break it down into two opposing forces, a gas pedal and a brake pedal. Just imagine for a second that your body is a high-performance car. The ANS is the driver, and it's got these two main pedals it uses to handle any situation you run into, perfectly balancing acceleration and braking to keep you running smoothly and, safely.
Okay, so these two controls have official names. On one side, you've got the sympathetic system. That's your gas pedal. You've probably heard of its nickname, fight or flight. It's all about consuming energy and getting you ready for action. And on the other side, there's the parasympathetic system. That's your brake pedal, or rest and digest. Its job is to conserve energy, slow everything down, and take care of housekeeping, like digestion. These two are in this constant, really delicate dance with each other.
And what's really cool is where these systems actually come from in your body. The sympathetic fight or flight nerves, they branch out from the middle part of your spine. The parasympathetic rest and digest nerves, they start way up at the top, in the brain, and way down at the bottom of the spine. And get this, there's even a third player called the enteric nervous system. It's this whole web of nerves just in your gut that's so complex, people call it our second brain. It basically handles digestion all by itself.
Okay, so we've got the big systems down, gas pedal, brake pedal, but how do they actually talk? How do they tell your heart to speed up or your stomach to start digesting? Well, the secret is in their chemical messengers.
And the answer is something called neurotransmitters. Honestly, the easiest way to think of them is as tiny biological text messages. A nerve fires, it releases these chemicals, and they shoot across a tiny gap to deliver a specific instruction to a cell, like speed up or slow down. It is an unbelievably fast and precise communication network.
And just like we have two big systems, we basically have two main chemical languages. The go message from the sympathetic system is mostly sent using a chemical called norepinephrine. That's the adrenergic system. The chill message from the parasympathetic system is sent using acetylcholine, and that's the cholinergic system. So simple, right? The gas pedal speaks adrenergic, and the brake pedal speaks cholinergic.
So let's actually follow one of these messages to see how it works. We'll use acetylcholine. First, it's made right inside the nerve. Then it gets packed into these tiny little bubbles called vesicles, kind of like little envelopes. When the signal comes, these vesicles dump the acetylcholine out. It zips across the gap, locks onto a receptor to deliver its message, and then, and this is so important, an enzyme immediately swoops in and cleans it up. That cleanup step is absolutely crucial. It makes sure the message is super brief and precise so the signal doesn't just get stuck in the on position.
Okay, so now we get to the really, really powerful part. Because once we understand this whole messaging system, how the texts are written, sent, received, and then deleted, we can actually start to interfere with it. We can learn to hack the system.
And here's the crucial point. This idea is the foundation for a huge part of modern medicine. Every single step in that process we just saw, making the message, storing it, releasing it, receiving it, and cleaning it up, every one of those is a potential target for a drug. By messing with these steps, we can treat an incredible range of diseases. So here's a famous example you've definitely heard of, Botox. It's not magic, it's just a really clever hack. What it does is it blocks step 3, It physically stops acetylcholine from being released, so the contract message never gets sent to certain muscles in the face. The muscles stay relaxed, and the wrinkles on the skin above them smooth out. It's a direct intervention in that cholinergic pathway.
And we can hack the system in the total opposite direction, too. Some antidepressants, for example, go after the adrenergic system. Instead of blocking the message, they boost it. They work by blocking the cleanup of norepinephrine, the gas pedal's messenger. This leaves more of it hanging around in the communication gap for longer, which amplifies its signal and can help lift a person's mood.
To get even more precise with our hacks, we can actually target the things that receive the message. These are called receptors. Think of them like specific docking stations built for very specific jobs. For example, a beta-1 receptor is found in the heart, and when it gets a go message, it increases the heart rate. But a beta-2 receptor in the lungs gets that same kind of message and does something different. It relaxes the airways. And then an M3 receptor in the eye works on the chill system, causing a muscle to contract. Different receptors, different jobs.
And this brings us to a perfect real-world example, treating glaucoma. With glaucoma, you get this dangerous pressure buildup inside the eye. So, to treat it, doctors can use a beta blocker, a drug like timolol. It blocks the receptors involved in making fluid, which lowers the pressure. Or they could use a different drug, like pilocarpine, which activates M3 receptors. This makes a muscle in the eye contract, which opens up a little drainage canal and lets fluid out. Two totally different hacks, targeting two different receptors, all to achieve the exact same goal. It's pretty amazing.
So, okay, we've gone deep into the weeds with nerves and chemicals and receptors. Let's zoom back out for a second. Why does any of this really matter? Why is understanding this invisible system so important?
It matters because this system is the balance of life itself. Every single moment of every single day, it's making countless tiny adjustments, perfectly turning your body's internal world to match whatever is happening in the external world. It's the reason you can leap into action in an emergency, but it's also the reason you can calmly fall asleep at night.
And its influence is just staggering. How staggering? Well, look at this number. Over 90%, more than 90% of everything your body does on its own every day, from breathing to your heart beating to keeping your temperature stable, is managed by this one hidden system. It is, without a doubt, the silent, unsung hero of our own biology.
Which really just leaves us with one final big question. We've already figured out how to hack this system to treat everything from high blood pressure to depression to glaucoma. So what's next? As our understanding gets even deeper and more sophisticated, what new ways are we going to find to tune this internal control panel? Not just to fight disease, but maybe to truly optimize our health and our performance. It's an exciting thing to think about. Thanks for watching.